Today's problem is submitted by a viewer, and it says, differentiate with respect to x, ax squared plus bx plus c times log of x plus square root of 1 plus x squared plus dx plus e times the square root of 1 plus x squared, where a, b, c, d, and e are constants. Simplify your answer as far as possible. And then it says, hence integrate log of x plus square root of 1 plus x squared and the square root of 1 plus x squared, and x times the log of x plus 1 plus the square root of 1 plus x squared. Okay, let's start with step 1 here of differentiating this thing. Okay, we'll just call this f of x. And we're going to differentiate with respect to x. So it's going to be a little bit messy. It's just a combination of product rule, chain rule, knowing derivatives of log and square roots and so on. Okay, so I think I've used product, chain rule, and every rule I need to get this expression, but I'm hoping to be able to simplify this a bit. I'm not sure if there's really much more simplification, any meaningful simplification that can be done. Like, you know, I could put that into a common denominator and then multiply through these denominators, but that's kind of messy. It's just going to end up with something not any nicer looking. This term is the only one with a logarithm. It's kind of not really going to go anywhere. And then again, I could maybe I could put this over a common denominator. There will be a little bit of simplification there. Let's maybe just simplify that last term. So the first two terms here, I'm going to leave the same. I don't think expanding or anything like that is going to make the expression any nicer. But then I'm going to write this as d times 1 plus x squared over the square root of 1 plus x squared plus d x squared plus ex over 1 plus x squared square root. And so now, you know, a little bit of stuff looks like it simplifies. So let's put this over a common denominator. And now in the numerator we have 2dx squared. So I'll put that there, get rid of that, and we still have a d left over. So that seems to be about as far as this thing can be simplified. Now the second part of the question gives us 3 functions that it would like us to integrate. And one of them I think shouldn't be an issue. So integrate log of x plus 1 plus x squared So what I'm going to do is I'm going to choose values. I'm going to let a and b, I'm going to let a equal 0 and b equal 1. And then maybe there are values of d, and then hold on. Like I would like to choose values of a, b, and c, sorry, a, b, c, d, and e, such that this whole expression is simply equal to that. It's clearly going to require a equals 0, and it makes sense I should just choose b is equal to 1. And then we'll have to figure out how to choose c, d, and e such that this disappears completely. So then maybe it is worth expanding this term as well. Yeah, and there might even be some cancellation with something there. Okay, yeah, before I get to this, let's continue with some simplification of this guy. So this term, let's change that to 1 plus x squared plus x divided by 1 plus x squared, like this. Oh, and yeah, we do get a cancellation. So that cancels that. And then we end up putting, there's more under common denominator. So I have ax squared plus bx plus c plus 2dx squared plus ex plus d divided by 1 plus x squared square root. Okay. And again, the numerator here is going to simplify. So I have a plus 2d times x squared plus b plus ex plus c plus d divided by 1 plus x squared square root. Okay, so now if we want to integrate this function that we're given, I want to choose, as I said earlier, a, b, c, d, and e such that this is equal to that. So a is equal to 0, b is equal to 1. This gives log of x plus 1 plus x squared square root plus 2dx squared plus 1 plus ex plus c plus d divided by 1 plus x squared. Okay, so I want d to be equal to 0. That'll get rid of that term. E to be equal to -1. That'll get rid of that term. And d is already 0, so c is equal to 0. And e equals -1. So let's put this all together. The original expression then, so ax squared plus bx plus c times a logarithm plus dx plus e times the square root, and so on. This will give x log of x plus 1 plus x squared square root. D is 0 and e is -1. So then it'll be minus 1 plus x squared, like that. So that is the integral of that. And that's just by taking the original expression we differentiated and substituting a 0, b is 1, c is 0, d is 0, and e is -1. Cool. And I guess we could check by differentiating this to make sure that you do get that back. I mean, obviously, product rule is going to leave us with this term immediately. But then the derivative of this gives us 1 over that times x, multiplied by the derivative of this, and so on. You can see it's not out of the realm of possibility that you get the correct cancellation. Okay. The second option, the second thing we're asked to integrate, I actually think is going to be a little bit more difficult. I'm going to come back to that one. Instead, I'm going to skip to the third one, where it says integrate x times log of x plus 1 plus x squared square root. So again, I'm going to go back to our general derivative here, this thing, and I want to choose the values of the constants such that this is equal to the function we want. So in this case, I need a to be equal to 1/2 and b to be equal to 0. This leaves us with x log x plus 1 plus x squared plus, okay, I'm going to copy this piece and bring it down. Okay, so a is 1/2. I'll make that substitution. B is 0, so we can get rid of that. So now I need D to be equal to -1 over 4. I need E to be equal to 0. And I need C to be equal to 1 over 4. Right, because then I'll have x log x plus 1 plus x squared plus, well, this will all be 0. Okay, so then the antiderivative of this will be the original expression with those constants subbed in. So let's take that original expression. Where is it? Okay, there we go. And so I need A to be 1/2. B is 0. C is 1/4. E is 0. And D is -1/4. There we go. And that should be the antiderivative. The derivative of this is this. And so we have essentially integrated this. We have an antiderivative. Okay. Lastly, it asks us to integrate 1 plus x squared under square root. But if I look at the general expression that I got for the derivative, where is it? Here, I don't actually have square root of 1 plus x squared anywhere. But if I choose the constants here such that the numerator is 1 plus x squared, then 1 plus x squared divided by the square root of 1 plus x squared is the square root of 1 plus x squared. So I want let's copy this. So I need a plus 2d x squared plus b plus e x plus c plus d. This should be equal to x squared plus 1. So I need b plus e is equal to 0. A plus 2d is equal to 1. And c plus d is equal to 1. So there's going to be more than one way of doing this. I wonder if that's odd. There shouldn't be the antiderivatives should differ only by a constant. Let's go b and e are 0. D is 0, C is 1, and A is 1. Then I have, I have f prime of x is 2x times the log of x plus 1 plus x squared, square root, plus x squared, d is 0, b and e are 0, c is 1, and d is 0. 1 over plus x squared. Yeah, so this just turns into, this whole thing simplifies to the square root of the thing in the denominator. Okay. So then the original function, I'll just copy it from what I have written on the message. A is 1, so that's x squared. B is 0, C is 1, x squared plus 1 times log. Oh, wait a minute. I see. I need everything. Yeah, I need the first part to be 0. So I need A is 0 and B is 0. So this means 2dx squared plus EX plus C plus D has to equal 1 plus x squared. So D is equal to 1/2. This says C is equal to 1/2 and E is equal to 0. Okay, now I can write down the antiderivative here. It's going to be log of x plus 1 plus x squared square root plus a half x 1 plus x squared. Cool. And that is the antiderivative or integral of that. Yeah, this was a kind of a nice problem. I've never thought about computing integrals by taking a really general complicated expression and differentiating it, and then just matching coefficients essentially. But that's pretty much what this is. We took some expression, which is some big complicated thing with a whole bunch of parameters in it, and differentiated to get some, additionally fairly complicated looking expression. But then that means we can integrate this for any particular values of a, b, c, d, and e. And there are, some fairly standard looking or common functions which can be found by substituting certain values of those constants in here. And so you just go back to the original expression, and that's your antiderivative. Yeah, I've never thought about doing it that way, but yeah, I suppose it works. That was pretty cool. In terms of this problem itself, like nothing in here was very complicated. Taking the derivative originally, it's a big messy expression, but we just used very elementary standard differentiation rules. And then the idea for continuing to the second part is really about this coefficient matching, and understanding that if you can match coefficients in the derivative, then you just have to take the same coefficients in the original function, and that'll of course be an antiderivative to the thing that you're trying to integrate. So nothing too special, just making sure you follow all the individual steps slowly and carefully, and you end up getting there. I don't have a way of checking the correct answer to this one, but I might have an arithmetic mistake here or there, but the general process I'm sure holds. Thanks for watching.